Hi, Lecturer Joe again. We started off this series of videos by talking about binary, how important it was because it was being used by basically all digital electronics, pretty much all electronics that we look at these days. And then we ended up by looking at hex. So if electronics are running binary internally to do their mathematics, why are we looking at hex? Well, these two are very closely related, and we can see that when we try to convert between one and another. So in previous videos we've gone from binary to decimal and from hex to decimal to put those into sort of values that we understand, decimal, base 10. This time we're going to look at going straight from binary to hex and hex back to binary. And it's actually easier than you might think. It's actually easier than going to decimal. So let's take a random number. 11010101. There's our binary number. And we'll put a little 2 there to remind us that that is binary. In order to convert that straight to hex, all we need to do, starting at the right hand side, is move it into groups of 4. 1, 2, 3, 4, dividing line, 1, 2, 3, 4, and we're finished there. So we've got 2 groups of 4. Now usually at that point what we do is we would, if we want to go to decimal, we would go 1s, 2s, 4s, 8s, 1s, 2s, 4s, 8s, and then 16s, 32s, 64s, 128s. Don't need to do that. If we want to go straight to hex, we can just repeat 1, 2, 4, 8. Having done that, let's look at this. We've got an 8, a 4 and a 1, which gives you 13. And here we've got a 4 and a 1, which gives you 5. Well, 13 in hexadecimal. Remember our scale goes 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So 10, 11, 12, 13, that's a D. And 5 is just a 5. So there is this number in hex, D5. So the value 11010101 in binary is D5 in hex without even going through the decimal stage. We still don't know what size of number that is yet. We could convert it either from binary into decimal or hex into decimal to see what it is. Well, let's do that actually. So we've got 13. If we look at this D5, because it's in hex, we know that those are 1s and these are 16s. So we've got 13 16s and 5 units. 13 times 16 and 5 times 1. 13 16s is going to be 160 and another 48, 208 plus 5 is 213, I think. So although we've converted it into decimal here so that we can get a feel for it, it's 213, we don't need to do that. We can go straight from binary to hex just by splitting the binary number into sets of 4. But you got to start from the right hand side and move across. So group of 4, group of 4, group of 4. Just an example the other way. So let's say we have the number F3C, and again that's a hex number. I put this little H to show that that's a hex number. And then now we just need to split that into 3 bunches. So we've got F here, which is 15. So all we need to know is how to write 15 in binary to take this whole number straight to binary. Well, 15 in binary is 1, 1, 1, 1. 3 in binary is going to be 0, 0, 1, 1. C in binary, which is A, B, C, 10, 11, 12, is going to be 1, 1, 0, 0. Now if you're thinking, well, how was I able to go straight to there? Well, I know that this is 3 because you've got a unit, a 1, and a 2, no 4s and no 8s, which gives you 3. 1s, 2s, 4s and 8s. An 8 and a 4, 2 and a 1 gives you 15, and an 8 and a 4 gives you 12, with no 2s and no 1s. 12 being C. So we're able to go straight from hex to binary, and that's just a single number then, which would be written all bunched up, like so. Straight from hex to binary without going through the step of decimal very quickly. And again, it's going to be important for you to be able to switch between these, because within PLCs often you'll find that when you're looking at the addressing for the memory locations, numbers are being coded in hex, and then when you're looking at individual bits in the PLC, they'll be as binary. So you've got to be able to work in both of these systems. And as before, in order to do the conversion, just go to one of the websites. There's binary to hex converter website. F3C turns out to be 3900 in decimal.